National Electrical Code Section 210.11c addresses the requirements for laundry circuits in dwelling units. The core principle to understand is that the code mandates the inclusion of a laundry circuit in the calculated electrical load for a dwelling unit regardless of whether the unit is actually equipped with laundry equipment or not. This requirement exists to ensure that the electrical system has sufficient capacity to handle a potential laundry load in the future, even if the current occupant does not utilize it for that purpose. The rationale behind this is to provide flexibility for future occupants who may wish to install laundry appliances. By pre-planning for this load, the likelihood of overloading the electrical system due to future modifications is reduced. This contributes to the overall safety and reliability of the electrical installation. To determine the specific load requirement for the laundry circuit, refer to the appropriate section of the National Electrical Code, which outlines the minimum amperage and voltage requirements. Typically, a dedicated 20 amp, 120 volt branch circuit is required for the laundry area. This circuit must be installed even if there are no immediate plans to use it for laundry purposes. The electrical load calculation for a dwelling unit involves summing up the anticipated loads from various circuits and appliances. The inclusion of the laundry circuit load is a mandatory component of this calculation. When performing the load calculation, it's important to consider the demand factors that may be applicable. Demand factors are multipliers that reduce the calculated load based on the assumption that not all circuits will be operating at their maximum capacity simultaneously. However, it's crucial to note that the laundry circuit load should generally be included at 100% of its rated value without applying any demand factors. This is because the laundry appliance, such as a washing machine or dryer, is likely to operate at or near its full capacity when in use. Ignoring the mandatory laundry circuit load can lead to an underestimation of the overall electrical load for the dwelling unit. This, in turn, can result in an undersized electrical service, inadequate wiring, and potential safety hazards such as overloaded circuits, trip breakers, and even electrical fires. Furthermore, failing to comply with the National Electrical Code requirements can result in code violations, fines, and the need for costly rework. It is imperative for electrical contractors, inspectors, and homeowners to be aware of and adhere to the provisions of Section 210.11c regarding laundry circuit load calculations. Ensuring compliance with this code requirement is essential for maintaining the safety and integrity of the electrical system and preventing potential electrical hazards. Remember that local amendments to the National Electrical Code may exist, so it is always recommended to consult with the local authority having jurisdiction to confirm any specific requirements or interpretations that may apply in a particular area. In summary, the inclusion of a laundry circuit load in the electrical load calculation for a dwelling unit is a mandatory requirement regardless of whether the unit has existing laundry equipment. This requirement is in place to ensure adequate electrical capacity for future laundry needs and to prevent potential electrical hazards. By adhering to the National Electrical Code and properly calculating the laundry circuit load, electrical professionals can contribute to the safety and reliability of electrical installations in residential buildings. The National Electrical Code, or NEC, is a comprehensive set of standards and guidelines for electrical installations in the United States. It is developed and maintained by the National Fire Protection Association, or NFPA, and is updated every 3 years to reflect advancements in technology and best practices in electrical safety. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. It is widely adopted by state and local jurisdictions as the basis for their electrical codes, although some jurisdictions may have local amendments or variations. Compliance with NEC is essential for ensuring the safety of electrical installations and preventing electrical hazards such as fires, shocks, and electrocution. The NEC is divided into chapters, articles, and sections, each addressing specific aspects of electrical installations. Section 210.11c, which pertains to laundry circuits in dwelling units, is just one small part of this extensive document. However, it is an important section to understand for anyone involved in residential electrical work. The NEC provides detailed requirements for the installation of branch circuits, which are the circuits that supply power to individual outlets, lights, and appliances. The NEC specifies the minimum wire size, overcurrent protection, and grounding requirements for branch circuits, as well as the permissible number of outlets or lighting fixtures that can be connected to a single circuit. The NEC also addresses the use of ground fault circuit interrupters, or GFCIs, which are devices that protect against electrical shock by detecting small imbalances in the current flowing through a circuit. GFCIs are required in many locations where there is a risk of exposure to moisture, such as bathrooms, kitchens, and outdoor areas. Overcurrent protection is another critical aspect of electrical safety that is addressed in the NEC. Overcurrent protective devices, such as circuit breakers and fuses, are designed to interrupt the flow of current in a circuit if it exceeds a safe level. This prevents overheating of wires and equipment, which can lead to electrical fires. The NEC specifies the appropriate size and type of overcurrent protection for different types of circuits and equipment. Grounding is also an essential element of electrical safety. Grounding provides a low-resistance path for fault current to flow back to the source, allowing the overcurrent protective device to trip and de-energize the circuit. The NEC specifies the requirements for grounding electrodes, grounding conductors, and equipment grounding. Proper grounding helps to prevent electrical shock and equipment damage. Electrical load calculations are an important part of the electrical design process. The purpose of a load calculation is to determine the total amount of electrical power that a building or electrical system will require. This information is used to size the electrical service, feeders, and branch circuits. The NEC provides detailed methods for performing load calculations for different types of occupancies, including dwelling units, commercial buildings, and industrial facilities. The NEC also includes provisions for demand factors, which allow for a reduction in the calculated load based on the assumption that not all electrical equipment will be operating simultaneously. However, it is important to use demand factors judiciously and to avoid underestimating the actual electrical load. In addition to the NEC, other standards and guidelines may be relevant to electrical installations. For example, the National Electrical Manufacturers Association, or NEMA, publishes standards for electrical equipment, such as enclosures, wiring devices, and lighting fixtures. Underwriters Laboratories, or ALL, is an independent testing and certification organization that tests electrical products to ensure that they meet safety standards. Compliance with these standards helps to ensure the safety and reliability of electrical installations. Electrical work should only be performed by qualified and licensed electricians. Electricians undergo extensive training and apprenticeship programs to learn the proper techniques for installing and maintaining electrical systems. They are also required to pass examinations to demonstrate their knowledge of the NEC and other relevant standards. Hiring a qualified electrician is the best way to ensure that electrical work is performed safely and in accordance with the code. Electrical inspections are an important part of the electrical safety process. Electrical inspectors review electrical plans and inspect electrical installations to ensure that they comply with the NEC and other applicable codes. They also verify that electrical work is performed by qualified electricians and that electrical equipment is properly installed and maintained. Electrical inspections help to identify potential electrical hazards and prevent electrical accidents. Electrical safety is a shared responsibility. Electricians, inspectors, homeowners, and building owners all have a role to play in ensuring the safety of electrical installations. By following the NEC and other relevant standards, and by working with qualified professionals, we can all help to prevent electrical hazards and protect lives and property. To recap on the specific instance about Section 210.11c, this mandates a laundry circuit, usually 20 amps at 120 volts, be included in the electrical load calculation for a dwelling, regardless of current laundry facilities. This anticipates future needs, ensuring sufficient capacity and safety, and preventing potential overloads or code violations. In simpler terms, plan for a laundry circuit even if there's no laundry room now. It's about future-proofing the electrical system and adhering to electrical code.